Good morning, everyone. So, today we are about to start our course about combination logics. As you might aware of logic gates, which you maybe studied before in another course, basically the combination logic refers to digital circuits whose output is a function of the present input signals only. So, in digital electronics or in the field of digital, it comes from the word digit. So, when we talk about the digital things, it refers to low and high level. The low level is shown by digit 0 and the high level is shown by digit 1. So any combination logic circuit, it is basically a combination of uh, different components to whom when you give a input, it will produce certain output based on the logic for which that circuit is designed for. So in other words, you can say the combination circuits, they are actually time independent circuits, and they are not dependent upon previous inputs generated by the other components. They in itself they are actually combination of different components and they produce a certain output. While the sequential logic, it is in contrast is it's not determined solely by the present input, but also by internal memory circuits and synchronous circuitry. So the difference between there is only a small difference between the sequential and combination logic circuits. Both are basically logic circuits, and the logic circuits, as I told you, they work on two levels, high and low, 0 and 1. Okay, based on that, when you give a certain combination of input means a combination of 0 or 1, low or high inputs, so they will produce a certain output on some logical function. That logical function could be addition, subtraction, multiplication, inversion. So there are different mathematical functions which are being used in the or being implemented in the circuits. Now the difference between combinational and sequential is you can say the sequential logic circuits, they are actually part of the combination circuit. You can think like that. The sequential logic circuits, basically their output is dependent upon the uh, circuit before that. Sequence means the word sequential comes from the sequence, means it is a logic circuit and it has some inputs coming from the another logic circuit. So the output of one logic circuit is going into the input of the second logic circuit. So that kind of combination is called sequential. So circuit A is giving its output to circuit B and circuit B is giving output as a final output or it is continuing to another circuit C. While the combination circuits, they are all in one package. They are a combination of different logic gates and you just give them certain inputs and they will produce you the final output. A combination logic circuit is a series of logic gates. Now the logic gate, what is this logic gate? There are some examples written here: and, or, not, XOR, and others. So it seems like they are normal English words, and, or, not. So how come these English letters are representing a term logic gates? If you remember, you studied with me transistors, diodes, and other electronic components in previous term in ENG 4215 and 4237. So if you remember, one application of transistor is logic gates. It means that the logic gates are actually made of transistors, and diodes also play a role in that. So the basic semiconductor components which we studied in our last term, those are the driving force behind the logic gates. These gates are acting on certain mathematical function. They are performing certain mathematical function. I give you a simple example. All of you know that 1 plus 1 is 2 because all of us we know mathematics and we have learned it. But a calculator, when you do 1 plus 1 on calculator, it is also giving you the same answer, of course. But how does the calculator know? Because it's a non-living object. How does it know that 1 plus 1 is 2? Or even if you give it a complex mathematical function, it will give you the correct result. So the behind the scene in the calculator, there are digital circuits, combination circuits. There are a lot of gates involved in there, and those gates are basically performing the mathematical functions of addition, subtraction, multiplication, division, half adder, full adder, squaring of things. So they are doing all sorts of mathematical functions with the help of logic gates. So these logic gates, basically we use them to do certain mathematical things, mathematical functions. And if you go further ahead, you can use the programming tools for the complex logic gate circuits, and you can do it, you can use it for more complex functions. Correct combination of logic gates can be used to implement in a wide variety of functions. Variety of mathematical functions, as I told you, like addition, subtraction, etc. So the bits are our friends. What are the bits? Bits means these numbers 0 and 1. So 0 represent low and 1 represent high level. So in this digital era, actually we are living in the digital era. Everything is digitized now. So all our communication, the communication when I'm talking to you and you are listening to me as I'm sitting in front of you, although we could be hundreds of kilometers away. So it's all communication is happening via internet in the form of digital communication, high and low level pulses. So low or high voltage on wire is basically transmitting my sound signal to you guys. Then another application is computation. Computation means all the mathematical functions which we were talking about, computing different numerical values. So in which they are using Boolean functions. Boolean functions are a kind of, you can say, it's another term is being used for Boolean algebra. Algebra which we use in mathematics. There is another algebra digital for digital values like 0 and 1. So it's called Boolean algebra. So basically they are also dealing with this mathematical functions, Boolean functions. And then is the storage. All of you, these bits, zeros and ones, any document which you write on Word or anything which you write on internet, you write email, all of that is stored somewhere. If you go to your email inbox, there are emails stored at somewhere at cloud storage. How that document, how your assessments, how any other thing which you write on your computer, how it is stored, that is stored, that the text or the information on that document is stored in the form of zeros and ones. So everything you speak or the videos or the text documents or anything that is converted into a cluster of zeros and ones, high and low levels. Okay, and that is then stored in the memory, because these digital components, they only understand the language of zeros and ones. If you uh, if you talk about alphabets A, B, C, D, they won't understand it. For each alphabet, they have an equivalent translation in the binary, or this zeros and one. So anything in English, for example, you write a letter, you make an assessment, or even you talk, you speak. I am speaking, and it's being converted into these bits, zeros and ones. So everything zeros and one, you can say it's a binary language, and it's another language. It's the language of the uh, digital things, and they only understand this language. So whatever we do, whenever we interact with computers, laptops, telephone, any digital thing, everything we do is converted into the binary code, into this zeros and ones. So that information in the form of zeros and ones, that is stored in the memory of these devices, or on the cloud storage, or anywhere. And from there, when you extract any information, that is converted back to your language, which is English, because you cannot understand. If you have a huge cluster of zeros and ones, what you will understand from there? So you need to translate it into your language. That conversion is being done by the same digital devices. If it is an audio, it will be converted into audio. If it is a video, it will be converted into a video. So that's what is happening in the background in fraction of seconds. That's how you receive thousands of channels in your home, and all that video, audio coming through the fiber optic cable into your home on your TV. That is basically on the background. That is basically all zeros and ones. They're all clusters and huge clusters of zeros and one. All the digital information. So that's another world. That's another language. So we have to interact with this. We have to understand the basic function, how this language works, and what are the components which deal with this language, which are the logic gates we will be covering in this course. So binary logic, it deals with the binary variables that take two discrete values. In binary language, in normal numeric language, the whole numbers, all of you know, the whole numbers are from 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. But when we talked about, as we explained to you about the digital field, it only uses the binary numbers, and it has only two numbers, two discrete values, 0 and 1. And with logic operations, there are some certain logic operations. There are three basic logic operations referred to as AND, OR, and NOT. What are these? We will be looking into it in a short while. Binary logic variables are typically represented as letters A, B, C, or X, Y, Z. So when we talk about the variables, as you know, in algebra, you express the variable with X. You might have solved so many questions in algebra, find the value of X or find the value of any other variable. So here we represent the variables using A, B, C or X, Y, Z. Same like that in algebra. So what are the binary logic functions? The binary logic functions, there are certain functions. These are some of the operators. Operators means this is the plus sign. You know that you already have been using it. The dot means multiplication. This sign here inverse, that means inversion. Inversion means giving the opposite out. If you are giving 0 to a box, that box is giving you 1. So it is giving you an inverted or opposite output. Variables, as the variables are representing certain value. So if you don't know the value, exact discrete value, then you represent it with the help of variables like x, y, z. The constant in binary functions are 0 and 1, as we already discussed. Grouping. When you are grouping something together, you use parentheses. Parentheses means these brackets like this bracket, or there are other brackets. These are called parentheses. So here are some examples shown to you. So this dot represent multiplication. Plus sign, you know, it's easy. Plus sign we all understand. And this sign here, this is the inverse sign. So here are some examples. Now this is and, or, and not. What are these actually? We will discuss it here. And means this function here, this one. If you look at this, this is the function in bracket a comma b. So and means you are actually multiplying a into b. Dot means multiplication. So and function, whenever you read here or that we are talking about and function, in the background you can think that we are talking about this multiplication function. So a dot b, f is 1 if and only if both a and b are equal 1. So this is logical. If any one of these two variables is 0, then the whole result will be 0. This is the basic mathematical function we all know. Now this or, what is or? The or function is represented here, and two variables a and b, it means they are being added. A plus b, simple. G would be 1 if either a is 1 or b is 1. That's very easy. So in simple addition, any one of them, if it is 1, other is 0, the answer will be 1. Now the third one, which is the not. So this function represent not. So what is that basically? The function a, if you give it apply a not function on this, it will give you an output a inverse. This small dash on top of a, you can call it as a inverse a bar. So inverse means it is giving the inverted output, opposite output. So if h is 1, then a would be h would be 1 if a is 0. Means if this a is 0, output you will get as 1. If it is 1 here, here you will get 0. In simple words, it is just giving you the opposite. So basic logic operators, that is continuing. That example, that AND function is being shown here in more detail, that if you are dealing with two variables 0 and 0 and you are applying AND function, and then the output will be 0. It's logical. 0 times 1, again 0. 1 times 0, that would also be 0. So there is only one possibility. If both variables are 1, only then you will get the answer as 1. If we talk about the or function, and if we are talking about two variables, so here you can see in all cases there is a 0 answer in only one possibility, when both are 0. When both are 0, the answer would be 0. But in other cases, even if one variable, one input is 1, then your answer will also come as 1. It's a
Teacher, I'm sorry for interrupting, but do you have the truth table for the gates?
Yeah,
I
we will
believe.
discuss that. Yes.
Okay, just like when you because if you do it beside these questions, like for and you put the and gate, like it will help, I believe so. Maybe.
Yeah, it's there and right on the next slide. So here you can see all that information which was we were talking about in terms of the applying mathematical functions and how these logic operations of and or how they are working. Actually, I'm going slide by slide. These slides are actually not developed by me, so they are given to me by the teacher who actually did that in previous term. So I'm continuing with that. So truth table is basically it's a combination of different inputs and their output, their relevant output. So truth table for different logic operators. So here this truth table is for AND gate, this is for OR, and this is for NOT. There are three basic logic gates. So if A and B are our input and F the function which is the output, so output is shown in this column while A and B inputs are shown here. So there are different combination of inputs which we can provide. Those are all mentioned here, and for each there is the output which is mentioned here. So because the AND gate performs multiplication function, so you can see it provides 0 in all cases except 1 when both inputs are 1. While talking about OR, again you will see A and B are the inputs, 4 combinations are there, multiplication is being done, and here there is only one case when you will get 0 when both the inputs are 0, while in all other cases your output will be high means 1. So here also 1 1, and there also it's 1. The last thing, not is very basic gate. It just gives the inverted output. So for anything, if you provide 0 it will give you 1. If you provide input as 1 it will give you 0. Okay, so that's all for today. Our session is almost going to end. So I will stop recording and I will open the forum for question answer session.